My name's Ollie Sinclair, CTO from Crimson. I'm just going to take you quickly through one of our housing AI insight scripted demonstration, just to show you the things that we're trying to pull together within Crimson. Now, before I start, the narrative is that behind the scenes there is a boatload of data sources and source systems where data and information is collated within Fabric. So these source systems would be housing management systems, asset management systems, case management, Outlook, emails, chat transcripts, etc. And I'm going to walk you through a demonstration of AI complaint root cause analysis, predictive repairs, and AI repairs assessment, as well as the regulatory grading. So actually looking at how we are doing from a regulatory perspective and matching all of this together. So what you can see on the screen here is the dashboard, where it's taken some information from my made up conceptual housing management systems. I've got 48 open complaints. There's already some AI on this dashboard that says that 11 are concentrated at a specific location. We've got 29 predicted repairs that may need to happen within the 90 days. 6 of them are high risk. And then we've got some reports awaiting triage around some repairs assessments. And it's giving you a bit of a feel for if we do some proactive management or some proactive maintenance on some of these areas, the projected savings will be about 184k related to these records. Now, as you can see on the dashboard screen, we have our agents that we can dip into, and we've also got a bit of a benefit story graph where in March, as you can see, we've only got 3 sort of reactive repairs that have been avoided, and actually we've got quite a lot of emergency repairs. This is supposed to show you that over time, with the introduction of this system as a solution, with AI embedded in the areas, that we can actually get much higher rates of avoiding reactive repairs and a lower rate of emergency repairs because we're maintaining and monitoring these elements. So the first one we'll have a look at is the complaints root cause analysis. Now, this is using a number of automation tools and data collation elements within Fabric, and then we're putting a AI wrapper over the top of that allows us to understand the context of the complaints and group them by a certain category. So categorization and subcategorization is a fantastic way to use generative AI to help out. We also have complaints linked by estate. So as you can see, that's where that Riverside estate insight has come up. And I've also got some generative insights, generative AI insights, where it's saying 35% of complaints in the last 6 months are around roofing, delayed roofing repairs, and it's specifically around Riverside Court and Apex Roofing Services. So we're also, trying to identify some of the root cause analysis, but it's giving me a bit of a recommendation there to create a dedicated roof recovery plan. So I could go ahead, speak to my maintenance guys or my head of repairs and start to having a look at how we can actually do that sort of plan. Gives me some other insights, category concentration, so roofing and contractor services, estate hotspots, and then a bit of a takeaway of what's going on here. The detail is obviously you can dive into, or you can drill down into the specific areas, but it's given me my recurring themes here. So 7 related complaints all relate to delayed roof repairs at Riverside Court. And what you can see is that my recommended actions are linked here. So again, just like the first one, where it says create a dedicated recovery plan, you can actually go and drill down into those individual underlying roof complaints, and you can see they're all on Riverside Court. Now, if it was around contractor response times, I could drill into this, and it says, look, I need to start to potentially introduce a same-day appointment confirmation and daily exception reporting around this specific contractor. And again, some at Riverside Court, but also Meadow House. So there's some statuses on these contractor response times, but you can also start to see that repair history and repeat visits show avoidable handoff delays. There's no link to Ombudsman on this one, but if I go into my roof repairs, there is already an Ombudsman case that's been linked. So not only can I find this information from my housing management system and my repairs system, as well as my asset management, I'm also linking my Ombudsman cases as well. Now, this helps set the context and gives us an understanding of what's going on within my complaints and having a bit of a root cause analysis on this area. Now, looking into maybe some of the predictive repairs. So behind the scenes, this is more machine learning, where we've put together quite a lot of detailed IoT analytical and transactional information related to individual components, as well as the repairs and the general details around the individual components for an asset. So you can see that Seven Meadow House has a boiler that's been 15 years old. And if you look at that, it says it's got a predicted probability of failure within 90 days is actually about 85%. And what I can do here, now that's great in terms of collating information, doing the analysis and setting a probability of failure within 90 days. But actually, I can actually schedule some proactive service units to go out and have a look at that. So rather than having to deep into the legacy source systems, I can trigger this action from my dashboard. So I'm going to go ahead and do that. It's going to go away and find out that actually it can be scheduled on the 15th of July, and that one has then, hopefully we can have a look at that. What you see here is not only you've got the prediction probability, but you've also got the contributing factors. So it's giving you that explainability about what AI has actually done. So it's had a look at some ignition failures, it's seen that there's been a missed visit, and obviously looked into the life of that component and actually pulled out the fact that it is an end-of-life component. So you can see that this assessment is done on multiple areas. So all of my sort of 90-day risk that are collated in the high area have those contributing factors. And what you can see is, again, my dashboard at the beginning, where we're talking about the length of time in months and how many repairs were avoided versus emergency repairs, and you can see that going up again there. So really, really useful in terms of machine learning to give us that probability score that we can then start to action. And now this is really important because, don't get me wrong, there could be a number of repairs or number of elements or assets that are needing of maintenance or needing to be having a look at. This gives you a far more targeted prioritized lists for your maintenance crew to go and have a look at. The other element is around deep learning, and this is around a management view for AI-assisted tenant repair reports. So the story is, as a tenant, I am able to jump onto my self-serving portal and create a repair request. And it asked me to capture a photograph of what's going on. Now that's great. That can, traditionally that would be captured and then sent into a mailbox. Then that mailbox would be, reviewed periodically by the maintenance team to actually assign the right sort of engineer, the right understanding of the SOR codes. But that takes some time, and usually it takes about 3 days to get through that. Now, that might be okay in terms of response times for simple fixes or low priority fixes, but what happens if they're urgent cases, like leaks in roofs, damp and mould, or leaking bathrooms? Now, what you can see here is that these submitted reports have gone into an AI queue that actually has automatically, through deep learning and models from Azure services, has actually seen that this is an issue detected, is actually a leak, and it actually shows that image. It gives you a description of what the image is trying to show. It gives you a confidence level because, again, none of this is 100% accurate. So again, we're using probabilities, but also it's a confidence score of 94% that the image shows water ingress across the ceiling line, staining close to a fitting, and the pattern is consistent with an unresolved roof leak. Surprise, surprise, we've got roof leak issues at Riverside Court. Also at Riverside Court, you can see that possibly, again, because of this roof issue, we're getting leaks, but we're also getting damp and mould. So the issues detected is damp. You can see that shows an extensive black and mould growth concentrated around the window frame and spreading and staining across, consistent with penetrating damp. So again, we can immediately identify these as high and urgent issues and be right at the top of the queue for us to actually schedule some maintenance. Not only can you see the details around the photo, but you can see contributing indicators. So it's given us a couple of tips around the discoloration pattern, visible moisture, and surface texture consistent with mold growth. But we can also pull in property context here. So we know that this is flat 12 Riverside Court, and we know the asset age, built in 2008 with external fabric repairs, are actually overdue, and the last repair was a roof leak investigation, and that's still open. So you can see that, you know, previous reports, there's 2 damp reports following roof complaints, all within Riverside Court. So you can start it to build a real big picture, and then you can actually have a look at the management action panel and say that, you know, you can upgrade this to urgent, and you can assign a rapid response repairs or schedule an inspection. So again, not only are you doing the analytics, but the AI is giving you some ideas around how to very quickly fix that and really start going. And then it's, again, what we're trying to do is make sure that we can keep managing how the services are being improved by sort of these AI solutions. And as you can see there, we've actually got the average time to triage down to 4 hours from 3 days, and now all of our urgent cases are being surfaced the same day. So really useful to get on top of AI for your your tenant repairs. What we've also do, because we've got all this information collated through Fabric and with that AI layer, we can actually have a look at how close we are to getting to a better grading and what things that we need to focus on. So yes, you've got safety, quality, transparency and influence, neighborhood, community and tenancy. We're red in 2 areas, we're amber in others. And what you can start to see is what's needed to move from a C1 to a C2 is all of these different sort of lower level metric root causes. So if I have a look at the fire risk, for example, you can see that contractor certification delays are extending closure times of the fire actions. We're also having a look at, for example, email responses, because we have data around our email responses coming in. The current target is 78, current is 78, and the target is up to 85. So really we need to make sure that we assign maybe a daily mailbox owner, or actually implement some more AI to actually have a look at how we can categorize and maybe come up with some suggested quick fixes around email responses within SLAs. So this is the type of thing that we're trying to look at. If you wanted to look at the raw detail coming out of this, we've got our references to our codes, we have our categories, and we can see all of the different areas, what the current status is, what happened last year, what the target is for this year, and then what the trend is on those targets. So really quickly, those 4 areas, we've put an AI layer over an architected Fabric data platform, which allows us to then do some really good proactive insights and start making some big changes. That's all I wanted really to take you through, guys, today. So thank you very much for your time. Goodbye.